I got two things written on the board, one on the left, one on the right. What do we call the thing on the left?
Expression.
An expression. And what do we call the thing on the right?
Equation.
Equation.
I just had a student today say,
What is an equation? Anybody know what an equation or what the definition of equation is? Take a wild guess. Yeah.
Like two expressions brought together by an equal sign.
Two expressions brought together by an equal sign. So we definitely have one expression, another expression, and then like an equal sign in between. Okay, we're close. Would this be an equation? Definitely not. Would this be an equation?
No.
Definitely not. We definitely need an equal sign. And we need an expression on the left and an expression on the right. Here's the actual definition. An equation is a mathematical statement that two expressions are equal. So an equation is a mathematical statement that two expressions are equal. So why is this an equation? Whoever said it was. Why is it an equation?
Because it's saying that 2x minus 3 is equal to 5.
Yeah, it's a statement that this expression is equal to this expression. Is this an equation?
Yeah.
Yes. Is this an equation? See everybody's thumb. Thumbs up, yes. Thumbs down, no. They're definitely not equal, we agree?
Yeah.
Is this a mathematical statement that two expressions are equal?
It's saying 2x is equal.
Mr. Whitman is 19 years old. Is that a statement?
Yeah.
Yes. Is that a true statement? No. Does it have to be true to be a statement?
No.
Definitely not. Okay. So is this a statement that one expression is equal to another expression?
Yeah.
Yes. This is an equation. Okay. This is an equation. And is the statement true?
Yeah.
Yeah, this is called a true equation. This is called a false equation. Is this equation red? Is it true, false, or neither? It depends on what the value of x is. If x is 3, it would be a true equation. If x is any other number, it would be a false equation. So this is neither true nor false. This is called an open equation. Okay. Basically, anytime you see a variable inside an equation, it's an open equation. All equations are either true, false, or open. This is very important. Is this an equation?
Yes.
Yes. X is an expression. X is an expression. This is a statement that two expressions are equal. This contains a variable. However, this is the rare case that this is not an open equation. This would be a what?
True.
True equation. So, but most any other time, like this equation is no longer true always. It's open. Okay. But almost every time, except for special cases, if an equation contains a variable, it's an open equation. Okay, we solved these 7th grade, 8th grade, something like that. What would be the first step? Subtract 5 both sides or add -5 both sides. Which property allows me to do that? Either the addition property of equality or the subtraction property of equality. If you add a negative, I just call everything the addition property of equality. And then what's the next step? Divide by 2. Okay, let me come back to this. So the directions were solve. What does solve mean?
Make the statement true.
Make the statement true. We'll come back to that in a second. Some people say find the answer. What else do we say?
Find the unknown value.
Okay, it's a possibility. So let's write down the definition. To solve means to find the solution set. We'll come back to what solution set means in a second. What is the solution to this equation?
X equals 3.
It is not x equals 3.
11.
It is 3. Okay. 3 is the solution. So what's it mean to be a solution?
Make the equation true.
Okay, this is very important. Here's the definition. A solution is a number that when replaced for the variable, it makes the equation true. Okay, so why is the number 3 a solution? Because when we replace it for the variable, we no longer have an open equation, we have a true equation. Okay, so a solution is a number that when replaced for the variable, it makes the equation true. Why is the number 7 not a solution? Because when it replaced for the variable, it does not make the equation true. Okay. Solution set, the definition is a solution set is the set of all solutions. So we still haven't solved yet because we haven't found the solution set. Well, we kind of did, but our final answer has to be a solution set. Is x equals 3 the solution? Why is x equals 3 not the solution? It's still an open equation. A solution is a number, not an equation. Okay? So the solution is 3, and the solution set, you simply take all the solutions, there's only one of them here, and we put it in these curly brackets. There's several ways to denote sets in mathematics. If we could list them all, we simply use curly brackets and put them all in there separated by commas. There's only one here. Are these 3 the same equation? They're definitely not the same. Okay. This is a statement that this expression is equal to this expression, which this expression is way different than this expression. And this expression is way different. And this is way different than that one. They're all different equations. However, they all have something in common. What do they have in common?
Same solution set.
The same exact solution set. Okay. Like the addition property of equality says you can add the same number to both sides of the equation, and the new equation is equivalent. Not the same equation, it's equivalent. So these are all called equivalent equations. Equations are equations that have the same solution set. another definition. So we use the addition property of equality to go to here. Here we use the division or multiplication property of equality, which says you can divide both numbers by both sides of the equation by the same number, and the new equation, as long as it's not zero, is equivalent, which means it has the same solution set. Okay. And once we get here, we know the obvious solution is 3 because we plug in 3 equals 3 with the solution set. Okay, let's try another one. The directions are solve. What does it mean to solve?
Find the solution set.
Find the solution set. And what is the solution set?
The set of all solutions.
Set of all solutions. You take them all and you put them in curly brackets. Okay. And what is the solution?
A number that when replacing with a variable makes a statement true.
Makes the equation true. A number that when replaced with a variable makes the equation true. Say it together. A number that when replaced for the variable makes the equation true. That's what solution is. Okay, first step here is add 8 to both sides. Next step, divide by 5 or multiply by 1/5, same thing. Is this my solution? No, we're getting better. I like this. What's my solution? 12/5 or 2.4 or something like that. And what is the solution set?
12/5.
So the way we say it, we say the set containing 12/5. When you write down, it's just curly brackets and you put the number inside. And why is 12/5 the solution? Because when replaced for the variable or plugged into the variable, it makes the equation true. Why is the number 0 not a solution?
Because it doesn't make variable, it doesn't make
Because when you replace the variable, it does not make the equation true. Okay. Let's do another one. Okay, here we got variables on both sides. So what's our first step? Subtract 3x. Subtract 3x both sides. And we got 4 equals 7. What does that tell us? Okay. So we use our addition property of equality. We end up with a false equation, always false equation. So what is the solutions? There's none. So is there a solution set?
No. Oh, yeah.
There is. Okay. It's simply this set. The set contains all of its solutions. Okay. There are no solutions to this equation, but there is a solution set. So can we even solve this equation? What's it mean to solve? Did we find the solution set?
Yeah.
Yes, we can solve this equation. We can't find any solutions, but we can solve it. Okay, because by the definition, we found the solution set. In fact, this is a very important set. Its own name is called the empty set. And in fact, it's so important we give it its own symbol. Okay. It's a circle with a slightly diagonal line through it. This is also the empty set. You could either write this as your solution set, or you could write this as your solution set. Simply is the empty set. In fact, it's one of the most important sets in all of mathematics. Is this the empty set?
No.
Definitely not. This is not empty. It contains another set. The set containing the empty set is definitely not the empty set. So don't ever write this. Terrible. You could either write this or write this. Don't put one inside the other. Okay. Okay. Let's try a new equation. This has lots of variables. So what are we going to do first?
Combine like terms.
Combine like terms. I like that. And now what? You could either stop here. This is always equal to this. If you wanted to, we could subtract 4x and get this equation. And it doesn't matter if you did that or not. And what do we end up with? An always true equation. So what are the solutions? Every single number we know is a solution. And what is the biggest set of numbers we know? All real numbers. Okay. Why is every real number a solution? Because when you plug it in for the variable, it makes the variables, in this case, makes the equation true. Okay. What is the solution set? Okay. The solution set is the set of real numbers. Okay. And there's lots of different ways we denote the set of real numbers. One way is we write it out in words like that. Another way is it looks like this. Have we seen that before? Okay. That is simply the letter R, but in boldface. That's not IR. It's boldface R. Right, when you're in Microsoft Word or whatever, how do you make something bold? We highlight it and press bold. Okay. But before computers, you couldn't do that. You had to make it bold by hand. And so back, who knows how long. Okay. They made it bold by making the left side put a line there. Okay. That's simply boldface R. It's just, that is the one way we denote the set of real numbers. We're going to learn another way. Some of you might know this. We do this. All the numbers between negative infinity and positive infinity. We'll typically do this way. This is called interval notation. How many of you guys learned interval notation last year? And not too many. We'll learn it beginning next week, I think. Okay. So some equations have one solution. Some equations have no solutions. And very similar equation, all of a sudden we have an infinite number of solutions. Either way, any equation we can solve, even if there's no solutions. Is this an equation? Why is it an equation? It's a statement that two expressions are equal. As long as you see an equal sign and some expression on the left, some expression on the right, it's an equation. Anybody know a solution to this?
Like, you just like say like x can equal 1, y can equal like 5.
Close. So this is fundamentally different because there's two variables. So we actually have to alter our definition. Where's our definition of equation? Here it is. An equation is a mathematical statement that, sorry, definition of a solution. A solution is a number that when replaced for the variable. This is really the definition for an equation in one variable. Okay. When we have an equation in two variables, it's a different definition. So let's write down that definition. A solution to an equation in two variables it's not a number. We need two different numbers. Okay. And right, for example, 1, 5, somebody said. or 1 for the x, 5 for the y, is the solution. So we had to know which number goes to which variable. And the way we denote that is an ordered pair. So a solution to the equation in two variables is an ordered pair, such that when the numbers are replaced for their respective variables, it makes the equation true. So it's not a number, it's two numbers. We call it ordered pair, such that when the numbers are replaced for the respective variables, the x for the x and the y for the y, it makes the equation true. So 1, 5 is a solution. Somebody give me another solution. 0, 3.
4.
Okay, interesting. I like that. 1/2, 4. 3, 9. 100, 203. -10, -17. And we could keep going. How many solutions are there to this equation? An infinite. Okay. There's no way we're going to write down all the solutions. So we're not going to do a curly bracket. Because we can't write them all in. So how are we going to write down the solution set? Any guesses? Okay, so what would I write? So all real numbers?
Yep.
And the range is all real numbers. So does that mean every ordered pair is a solution?
No.
It's definitely not. 0, 10 is not a solution. So we can't just write down the domain range. We'll talk about what domain range mean in a minute, but how are we going to do this? Because we know lots of numbers that are not solutions. Sorry, lots of ordered pairs.
Could be like a linear
This definitely is a linear equation. Okay, in fact, you've written down the solution set to this many, many, many times. How do we do it in 8th grade?
Oh, good make a graph.
We graphed the solution set. Okay. We draw a coordinate plane. So when you graph linear equations in two variables in 8th grade, and you probably did a bunch last year too, you're really just graphing the solution set. All the ordered pairs that when replaced for the variable make the equation true. This line is simply an infinite number of ordered pairs. Every single ordered pair on that line is a solution. All of them together is the solution set. Okay. We could have graphed the solutions for these. These are actually also called linear equations, but only in one variable. We could graph it. There's only one variable. We need only one number line. We could put a dot right here on 12/5, and we graph the solution set. We put a dot on every solution. We don't do that because it's pointless. I mean, it's a lot easier to do this. Okay. We could have graphed this solution set here, and we put a dot on every single solution, which is all real numbers. But we don't do that. Okay. But we do graph the solution set to linear equations in two variables. It's really the only way to write them all down. There are some other notations, but we don't need to worry about that right now. Okay. This tells you what is a solution and what is not a solution. Okay, so did we solve this equation? Yeah, why did we solve it?
Because we found the solution set.
We found the solution set. Okay, so this is very important. We're always either going to start with an expression that's fast or an equation. Okay, this very first equation, very first expression I wrote up here. Can we solve this? Why can we not solve it? It's not an equation. To solve means to find the solution set. A solution set instead of all solutions. A solution is a number that replaced for the variable makes the equation true. There's no equation. Expressions are neither true nor false. Okay, it just is what it is. Okay, you cannot solve this. You can solve this, an equation. Okay, so when you look at something around the board, it's either going to be an expression or an equation. We do totally different stuff. Almost always we solve these. Expressions we can manipulate them. You could rewrite them. You could factor out a number. You can change it, manipulate it, simplify it, complexify it, but you cannot solve it. Very important. A new definition. The definition of a relation is simply a set of ordered pairs. It's called a relation. Is this a relation?
Yes.
Yes.
Yes, what?
This is
an
an
example.
example.
Curly brackets mean it's a
Set.
set, and inside, separated by commas, are
Ordered pair.
ordered pairs. This set of ordered pairs. Okay. This has a very clear pattern. Well, it should be clear. 1, 3, 2, 5, 3, 7. What's the next one?
4, 9.
4, 9, so on. If there's a clear pattern, you just put dot, 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 the ellipses. Okay, so here, this is a relation. Why is this a relation?
What did you just say?
Why is this a relation? Because it's a set of ordered pairs. That's why. Because there's the brackets and there's everything inside is ordered pairs. This has an infinite number of ordered pairs in it. Okay. Okay, there are three ways to denote relations. First way is you list the ordered pairs, just like we did here and here. It could be in a table too. It doesn't necessarily have to look exactly. Okay, you can list them like that in the correct roster. This is called roster notation. You can put them in a table. You can go 1, 5, -4, and put arrows. 5 and 2. Okay, it doesn't really matter as long as you're listing the order pairs. The second way, what else can we do with order pairs? Just like we did up here, we graph them. You can graph the relation. Thank you. It could be like this, or like we did earlier, we can have an infinite number of ordered pairs. That's typically when we graph a relation, when there's an infinite number of them. And then what's the third way? Anybody want to take a guess what the third way is? This was the solution set, this guy, right?
Oh, yeah.
Okay. So the third way is we write down an equation. Okay. However, an equation is not a set of ordered pairs. Okay. So if we write down y equals 2x plus 3, this is not a set of ordered pairs. But what about this is a set of ordered pairs? The solution set. So an equation, it's the solution set. Okay. It's the solution set that is the set of ordered pairs. It is the relation. So we'll call this a relation. Technically, it's not. It's the solution set to this is the equation. Because the solution set is the set of ordered pairs. Okay, so those are three ways we denote relations. Is this an equation?
Nah. Wait. Sometimes.
Say yes.
Definitely not.
Oh.
Is that an equal sign?
No.
No, definitely not an equation. What do we call this thing?
Inequality.
An inequality. Okay. Can we solve inequalities? What's it mean to solve?
Find the solution set.
Okay. It means to find the solution set. What's the definition of a solution to an inequality?
A number that would
Actually, let's go back. What is an inequality? What is it?
The statements are unequal.
Close. Not really.
Comparison.
Sort of. It's almost the same definition as equation. Where's equation?
For a mathematical statement that two expressions are less than or greater than or equal to.
Okay, so instead of equation, it's going to be an inequality. We'll write this down in a second. Is a mathematical statement that one expression is either less than, greater than, less than or equal to, or greater than or equal to another expression. So let me write that down. An inequality is a mathematical statement that one expression is less than or greater than or less than or equal to or greater than or equal to another. I could have wrote out the words less than, greater than, or less than or equal to, or greater than or equal to another expression. Okay. A solution to this, is it going to be a number or an ordered pair? A number, why?
Because there's only one variable.
There's only one variable. Okay. How many solutions does this have?
All real numbers less than 5.
Okay.
Or 5.
Is 0 a solution?
Yeah.
Yes.
Yes.
Is 3 a solution?
Yeah.
Is 4 a solution?
Yes.
Is 4.5 a solution?
Yes.
Is 5 a solution?
Yes.
Yes. Why is 5 a solution?
Because it's equal to or equal to.
When replaced for the variable, it makes the inequality true. Because of the or equal to, this is true. Okay. So it definitely has an infinite number of solutions. We can write them in something called interval notation. We'll learn that probably Monday. Right now, we could just graph the solution set. Since there's only one variable, we need only one number line. Okay, and you simply put a dot on every single solution. And you did this last year, correct? Solved inequalities. And you typically graph a solution set. Let's go -9. What was our first step? And then divide by 2. Do I have to flip the inequality sign?
No.
No, because we're not dividing or multiplying by a negative. Is this my solution set?
No.
No. All three of these are called equivalent inequalities. Okay. So we're going to graph the solution set. We got to put a dot on every single solution. Is the number 3 a solution? I'm sorry, is the number -3 a solution?
No.
No. Okay. We have to just remove one tiny point. Okay, it's very hard. If you pull that one tiny point, you'll never see that it's gone. So we exaggerate it, make a big open circle. Even though, do that. Okay. Again, there's going to be a better way to do the solution set, but for right now, we're just going to graph the solution set. Okay. All these definitions are very important. What's it? An equation mean? What does it mean to solve? What is a solution set? What is a solution? What are equivalent equations? All equations are true, false, and open. We got to memorize these, know them by heart real quick. We will have a quiz probably in the next week on the definitions.